Now we've been talking about significant figures in the respect of how to read the instruments. Okay, all right, and we've done that. We've read a lot of the different instruments. I think by now we know how to do it. I've shown you how to read all the instruments you're going to use throughout the year: the scales, the thermometer, the graduated cylinders, the beakers, everything you're going to use throughout the year. You know how to read correctly now to the right number of significant figures, even the rulers. All right, but there's a reason for significant figures, something that you don't realize at this point. And there's a problem with significant figures, something else that you don't realize. All right? So I want to show you. First of all, here's the main reason I want to eventually get significant figures. All right? You know how you get a problem like, what's going to happen if I divide 3, don't do this, 3 divided by 9? What am I going to get?
1/3.
No. I'm going to get 1/3, which on my calculator is going to come out to be what? 0.3333333, right? Okay? Now, do you really think there are an infinite number of significant figures in that answer? No. And what has everybody always told you to just do? They've always said, oh, round it off to 2 decimal places, or round it off to 1 or round it off to the whole number. That's what you've always been told to do. That is not correct. It's fine for math, because math doesn't have a problem with infinite numbers. But we do. We know that we use this ruler, and that ruler only had, precision up to 1 decimal place or 2 decimal places or whatever. And I can't very well create or destroy, it says log constant.
16, from 17, and from 19.
Wait! It could be a little late. It's okay. We can't very well create or destroy significant figures either. All right, just like we can't create or destroy, matter or energy. So, what are we going to do? Well, I got to show you how to keep significant figures when doing calculations, and just determining how many are significant. And here's the second problem. I told you there's 2 problems. That's one, the calculations. But what I want to talk about first is actually this. Let's say I measured something on my ruler, and it was 48.5 centimeters. Okay? Now, let's say I want to, let's make that 48.5 kilometers to make it easier. 48.5 kilometers. Okay? Now, if I ask for that same number in meters, that number would be, can anybody do that in their head? We're going to learn how to do metric system yet again. What would 48.5 kilometers be in meters? What do you think? 48,500. Okay, that's how many meters there would be. All right? And what if I wanted it in millimeters? What would the answer be? 485,000,000, right? Okay? Now, if you don't remember how to do this, don't worry. I'm going to teach it to you all over again. But here's my point. How many significant figures were in this guy? When you read your scale, you have 1, 2, 3 significant figures to 1 decimal place, correct? Does this guy have 1, 2, 3, 4, 5 significant figures? And does this guy have 1, 2, 3, 4, 5, 6, 7, 8 significant figures? Did I just create significant figures by changing the units from kilometers to millimeters? No, I can't do that. I can't just add significant figures and make the instrument better than it was. All right? Those zeros are just placeholders. And you have to be able to tell a difference between zeros that are significant and zeros that are placeholders. Sometimes they're just placeholders. And sometimes it's easy to tell. And other times it's not. So you guys are going to just got called down. I want to go through this with you first. Trust me, you'll get there. As soon as I'm done with this, I'm going to take a break in about 15 minutes, let you work out the problems, then you guys can go down. But you want to hear this because these zeros are confusing. Okay? These zeros are very confusing, and if you aren't here, you're not going to know what's going on here. Okay? All right. Let's learn how to tell which zeros are significant, which numbers are actually significant. Basically, there's a rule. There's actually 2 rules. If you were to look this up in a book, and I've seen this in books, there are probably about 7 rules, and they're very confusing and stupid. Really a waste of time memorizing it. This is all you need to know. It's a trick more than a rule, but it works, and it works great. If there's no decimal in the number, now I'm just going to tell you these 2 rules first, and then we're going to learn it by practicing it. Okay, it won't take me that long. I'm not going to be teaching this whole period. You're going to be working on some of these for a good portion of it. Let me just give you the rules. At first it'll say, I'm not sure what you mean. It'll become clear when I do my examples. If there's no decimal in the number, you draw a line from the right-hand side of that number, and all those zeros that you're going to go through are insignificant until you hit the first non-zero number. So write that down. And remember, I know right now, what does that mean? And I'm going to give you another go, I don't know if you will. Just give me 2 seconds. I will show you with some examples. All right, so that's the first rule. If there's no decimal in the number, this always works. It's kind of a cool little trick. It always works, rather than, like I said, there's in your book, if you were to look up rules for this, there's like 7 rules. It's a little crazy. If there is a decimal, you do exactly the same thing, only you draw the line from the left instead of from the right. Now, that's pretty easy to remember, and it's pretty easy to do. It's a very simple formula for doing these. I'm going to give you a bunch of examples now, and then I'm going to let you practice it while half of you go down, whoever's got called down for their pictures. All right, let's start out with a guy who doesn't have any zeros. Okay? First problem I'll put up here, I want to put, for every one of these, I'm going to have a column. The example, the number I'm going to do, and then how many significant figures there are in that number. Okay? So we're going to fill in this chart. And that's all we're doing. This board is the end of my notes for today. Well, not for today, but for the first part of the class. And I'm going to let you work on some practicing. Okay? Let's start out for a guy who doesn't have any zeros. A guy like that, 245. Okay? If there aren't any zeros, if it's an actual number, non-zero number, everybody there is significant. So 1, 2, 3 numbers, 3 significant things. Oops, I'm sorry. 3 significant things. 3 significant figures. That's how many I have. All 3 of them are significant. Simple enough. All right? Now, let's throw some zeros in there. What if I have that? Let's apply our rule. Is there a decimal in the number? Yes. If there's a decimal, I draw a line from the left, and I cross out any zeros I run into before I hit the first non-zero number. Bam. I immediately hit a non-zero number. You know what that tells me? Everything that follows, 1, 2, 3, 4, 5, 6, all of those numbers are significant. It means they were actually used to get that measurement using that scale, whatever that scale was. Okay? That won't be the case in everything here, as you'll see in a second. For example, let's look at this one. Same rule is going to apply. Is there a decimal in this number? Yeah. So I will draw a line. I want you to watch now. I'm going to draw my line and cross out all my non-zero numbers until I hit the first, all my zeros until I hit the first non-zero number. And then everything after that is significant. How many significant figures are there in this problem? Only 3. Only 3. Very simple rule to apply. Okay? By the way, the reason this happens, and the reason this is important, you're going to see it in the next half of the class. But the reason it happens, that we actually get these extra zeros on there, is mainly from metric conversions, converting from kilometers to meters to centimeters to millimeters. You get placeholders. These zeros are just placeholders. They were not used to actually get the measurement. They were simply holding a place to give it its actual metric conversion. All right, let's try another one. How about that guy? Now, some people will say they have 1, 2, 3, 4, 5, 6, because they're going to use the same rule I've been using, where I draw my line to the left, but that's not correct. Is there a decimal in this number? No. If there's no decimal, I draw the line from the right. See how easy this is? How many significant figures are in this guy? 3. You may also notice I'm playing around with 245 all over the place, right? Let's try another one. How about that? Now, you get used to just getting rid of your zeros. So you start to think to yourself, okay, 3 again. Is 3 the right answer? No. Is there a decimal? Yes. If there's a decimal, what side do I draw the line from? The left. And I hit my first non-zero number at that point. Everything that follows is significant. Everything after you hit that is 1, 2, 3, 4. Now, that's where people will go wrong. They'll say, but I thought if it ends in a 0, I automatically start from the left, from the right. That's not what I said. Where does it say up there, if there's a 0, no, it says if there's a decimal or not. That's all that matters. If there is a decimal, like there is in this one, I got to start from that side. If there is no decimal, I have to start from this side. You understand? All right, let's try a couple more, and then we'll be done. I'll let you start on your problems. How about that guy? Everybody put your own answer down for that one. How many significant figures are in that guy? Let's see if everybody gets the same answer. Did y'all put down 5? Because there are. If there's a decimal, start from the left. There are 5. All right, one more. You will sometimes see these guys written, and I'll tell you why this happens sometimes with a bar over them. If there's a bar over this guy, all right? So you write 2450000 with the bar over that first 0. Well, you still apply the same rule. There's no decimal. I start from the right. But you're like a drunk. You stop at the bar. Get it? You stop at the bar. You stop at the bar, and then everything after that is significant. 1, 2, 3, 4. 4 significant figures on that one. Okay? If there's a bar. By the way, you might wonder, why would you ever put a bar? What's the point of putting a bar over 0? Here's what you're saying. Remember a minute ago I talked about, let's just say 24.5. Let's say I measured something on my ruler that was 24.50. That 0 is significant. That's what I measured. Then I convert it into, all right, that was in kilometers, and I converted it into meters. 1, 2, 3 spaces. So I make it 24500. And you guys will be able to go too in a minute.
22
1 second.
and 23, please record.
All right, you'll all be able to go in 1 second. All right. Here's what I'm saying. This guy, when it was 24.50, I used the ruler and I was estimating. Remember how you had to add zeros sometimes? And they were significant. They were saying it was right on that line. Well, when I converted them to meters, I want to show that guy's still significant, so I put a bar over him. That's when that happens. And that way it shows that I still have 4 significant figures. That'll become much more apparent in a little while, in the second half of this class, all right, after you get back. Meanwhile, before you leave, copy this down so when you get back you can start working on it. That's the homework that everybody else is going to be working on right now. All right? After you copy that down, go get your pictures taken, those 2 homeworks that were called.